Consider the transition diagram of a push-down automata given below with input alphabet sigma equal to a comma b and stack alphabet equal to x comma z. Z is the initial stack symbol. Let L denote the language accepted by the push-down automata. Which of the below is true? And we have been given 4 options here. So this is a question coming from theory of computation section regarding push-down automata. Now let's take a look at the push-down automata here and see what language it generates, what strings it generates. So this was the starting state. Okay. So starting state itself is an accepting state. So epsilon is accepted by this push-down automata. Now initial stack symbol would be Z, that was given in the question. Z is the initial stack symbol. Okay. And it is saying on seeing A and Z on the stack, we will be pushing X on top of the Z there. After that, on seeing A and X on top of the stack, we will be pushing X on top of the X on the stack, which means that as long as we keep on seeing A, that string will be accepted by this push-down automata, since this is an accepting state only, which means on top of epsilon, all strings of A, n number of A will also be accepted by this language. Okay. Now we have epsilon A, etc. here. Now after seeing some A's, if it sees a B and X on top of the stack, it will be popping that X from the stack and it will be pushing nothing. So it will be just popping that X from the stack and going to this state. After that, when it sees B and keeps on seeing X, it will be keeping on popping the X on top of the stack, from the top of the stacks, until it sees the initial stack symbol Z. At that point, it will just neither push nor pop anything, it will go to an accepting state. So this is nothing but accepting strings of the form a power n, b power n, such that n is greater than or equal to 0, n is greater than 0. There should be at least one A which will pop at least one X, which will push at least one X to the stack. After that, at least one B will pop that X. After that, if it sees the initial stack symbol, it will go to the accepting state. So that part will be nothing but a power n, b power n, such that n is greater than 0. Now let's take a look at the options. The first one, it says that language is a power n, b power n, such that n is greater than or equal to 0. That is false, because that doesn't cover this part. The language can also generate strings of the form a star, right? So this part alone doesn't cover this. Now option B, a power n such that n greater than or equal to 0, that is correct. It will is covering all of these. Union a power n, b power n such that n is greater than or equal to 0. Now this part was generating a power n, b power n was n greater than 0. But if n is equal to 0, this is nothing but epsilon, that's already covered here. So this is fine. A power n, b power n such that n is greater than or equal to 0, union this is fine, and is not accepted by any deterministic push-down automata. Now this part of the statement is false. That's because, see, we only have to do either one of two things. One is, as long as we keep on seeing A, just push it to the stack and keep on accepting all the strings. After we see at least one B, we will be keeping on popping whatever is there in the stack until the stack becomes empty. After it becomes empty, if there is nothing else, we will be accepting it. So this can be easily done by a deterministic push-down automata. There is nothing non-deterministic about this. So this part of the statement is false. So B is also false. If you look at D, it's the same, except this part. It says that L is equal to a power n such that n greater than or equal to 0, union a power n, b power n such that n greater than or equal to 0, and is deterministic context free. Now that is correct. Option D is the right answer. Now if it is deterministic context free, definitely it can be accepted by a Turing machine that halts on every input. So saying that it is not accepted by a Turing machine is false. So option C is also false. D is the right answer for this.